So today we're going to talk about ECS and Docker, what is Fargate, the Fat Lambda strategy, a real-world use case of Fat Lambda strategy, and I'm going to give you a demo of how to actually create one of these Fat Lambdas. So ECS is the one of the core components of this strategy that I'm going to talk about. It's the Elastic Container Service on AWS. So that means you can run, stop, and manage Docker containers on EC2 clusters. You can run one-off tasks, that'll be like a Lambda, where it just fires up and then shuts itself down. Or you can have long-running services, like you can have web servers or databases on these Docker containers. So what are Docker containers? So Docker containers are kind of like virtual machines, but without the whole hardware emulation side of the virtual machine. So they're a lot lighter than virtual machines. They're just the app layer. So it has the app and everything you need to run the app inside of it, including the entire environment. So you can have different kinds of Linux or entire web servers inside this container, run it on a host, and have it isolated from everything else on your machine. But it can still access other things on your machine through the network layer. So you can network all these together through the local host. So why use Docker containers? So Docker containers are very developer friendly as opposed to virtual machines or having them install all of the software on their own machines. You can run isolated architectures on the local machine that will run the same as if it were running on production. And the containers are defined in a text file, so you can check in that text file to source control and share it with other people. So on AWS specifically, we have ECS, the Elastic Container Service, and that can run Docker containers. You can create a cluster of EC2 instances to run these Docker containers, because as you saw in the previous slide, you're not defining the whole virtual machine. It still has to run on a host. So you can either create an EC2 instance that will run Docker, or you can use Fargate to just throw your Docker containers out into the wild, and AWS has a managed EC2 cluster that will run your Docker containers for you. And you can create custom Docker images in AWS and push them up to this Elastic Container Repository that's also inside of ECS. So Fargate is relatively new. It was announced in November during reInvent. It's an alternative to the EC2 clusters you normally would have to set up for ECS. So ECS involved not only creating these Docker containers, but you had to create a cluster of EC2 instances that would auto-scale and you'd have to manage all that auto-scaling and set up all the security groups and everything like that. And that was a little bit of a barrier to use ECS. But they've gotten rid of that barrier with Fargate. So Fargate is just a managed cluster by AWS where they will manage all the updates you need to perform on these EC2 instances and make sure everything just works. So you can deploy Docker containers without worrying about scaling of clusters or maintaining the instances. So you can run one-off tasks, which I'm calling Fat Lambdas, or you can run services that are long-running tasks, like web servers and databases. So Fargate's not a direct replacement for Lambda, but it does get rid of some of those limits that you run into with Lambda, which is Lambda is the traditional serverless option with AWS. So Fargate's the more recent offering. But with Lambda, you have certain limits. So in Lambda, you have a 5-minute max runtime. So if your task runs for more than 5 minutes, it'll just shut down. But in Fargate, you have no time limit. You can run it as long as you want. Lambda also has a 512 megabyte disk that you can work with, while Fargate has a 10 gigabyte disk. Lambdas also have between 128 megabytes of memory to 3 gigabytes of memory, while you can go up to 30 gigabytes with Fargate. And also with Lambdas, you only have 50 megabytes of compressed code size you can work with. But with Fargate, you have 4 gigabytes of container image layers. So 4 gigabyte per layer, which I'll touch on later, what a layer is. Lambda, you also can't control how much CPU you get. It's just based on how much memory you specify. With Fargate, you can specify between a quarter of a virtual CPU to four CPUs. So that's roughly equivalent to like a extra large instance. So what's the Fat Lambda strategy? So Fat Lambda is just an ECS task that is run in Fargate. So it's a serverless ECS task. So it just means a Docker container that runs and then shuts itself down without you having to specify any kind of EC2 instance for it to run on. So when a task is too big for Lambda, you should switch to the Fat Lambda strategy. And I'll talk about a particular use case we ran into where this made sense. So the strategy implementation. So when you're writing code with your for Lambda, you can write with Python, you can write with Go, you can do C# now, and Java and JavaScript. So you can take that code and wrap it into a Docker container for a Fat Lambda. Then you just have to deploy that container to the Elastic Container Repository, and then you can run that container as a task in Fargate. Now these containers can be scheduled with CloudWatch, or you can use some other trigger like the Lambda to actually trigger it. So Lambda and these ECS tasks work really well together. So if a task is too big when the Lambda is running, you can just pass it off to the ECS task. So eventually, when you're using Fargate, you should still consider converting to an EC2 cluster if price is a concern or you need to control more power, or you need more power over the settings. So I'll talk about it as well too. So we had a goal to have a near real-time ETL process. So ETL is a process to load a database or a data warehouse. So we were loading a Redshift data warehouse from log files that were posted to S3 every 5 to 15 minutes. So we could have a bunch of log files coming in from various sources, and we wanted to just load them in the data warehouse and then transform the data and then clean everything up. We tried Lambda and step functions. So we tried Lambda originally, but it was running for more than 5 minutes because we have no control over how fast the ETL process runs because it's actually running inside of Redshift. We're sending commands to Redshift to load the data. We're sending SQL commands. So basically, we're just sitting there babysitting these commands, and they would just time out because it exceeded the 5-minute limit, especially during the vacuum phase. So there's this phase in Redshift that's familiar to Postgres where you vacuum your data because Redshift, as you're inserting and updating data, it'll just keep old data in there, so it'll move faster. And then you have to call this vacuum command to resort the data and clean out all the old data. That can run for a long time if it's if the Redshift cluster is not very big or if there's a lot of data. So we went from Lambda and we switched to step functions. We tried to break down our Lambda into smaller steps. We thought that would be a better way to extend our runtime in Lambda. But that one step, the vacuum step, still ran over 5 minutes. So the step functions didn't work. It was DOA. But also we found that they were difficult to work with because you had to run them on the cloud. There was no way to run the step functions locally. So we had to deploy it, and have it write to log files and then figure out where it went wrong there. We couldn't just set breakpoints or anything like that or run it on our local machine. So we decided to go with the Fat Lambda strategy. So here's the architecture we ended up with. It actually ended up being really simple. So we had all these log files coming in to S3. And as they came in, S3 has the option to send an event to SQS declaring that the file exists. Then they would just get queued up inside of there, so we'd have as many files as we needed in there. And there's a CloudWatch event happening here that just set off an event every 1 minute to fire this Lambda. And all this Lambda does is it checks if the ECS task is running or not. And if it's not running, then it'll start the ECS task. That ECS task will then pull up to 1,000 messages from each queue that we had here and create a manifest file to load into Redshift and then it would copy everything over to Redshift and then do the rest of the sequential ETL load. So transform the stage data and then vacuum it all up. All right, so let's do a demo of a Fat Lambda handoff. So what I'm going to show you is how you write this Lambda that'll fire off this ECS task and then deploy it to Fargate to have a serverless Docker container running in AWS. Now ultimately, all this Docker container is going to do is write a log message. You guys are keeping it super simple. But it could do anything. You could give it roles. It's operating in AWS. You could give it roles to access your S3 buckets, which we did. You give it roles to get credentials from Redshift, so you don't even need login credentials stored in your Docker container. It'll just automatically pull down credentials based on that role, which we did. You could have it post to SNS. You could post to SQS. You could do anything. You could interact with all the other services in AWS. It's like a truly integrated experience, just like Lambda. So before you can really develop with Docker and Fat Lambda, you need Docker Community Edition and the AWS CLI. Now I have some starter code for you at this link that I've loaded up on my machine. And then I'm going to show you can build the Docker image locally, and you can run it locally to test it. So let's do that. So here's the code that you'll see when you go into the GitHub repository and pull it down. The README is very sparse right now. I'll add more to it for you guys later so you can follow along. But all I have in here is this demo file, and this is where the Docker command will run. So this is just straight Python. It's just importing logging, which is a standard Python library. It's setting up logging to have the info level and to have this format that I like that shows the line number and file name that the log message happened from. This is for debugging purposes. And then it just logs this message that the Fat Lambda started. Now it also has a Lambda method in here that we'll get into later. Now the other part of this is this Docker file. Then we have from Python 3 Alpine as the first line of the Docker file. So there's all these images that you can find on Docker, on the Docker Hub, that you can start from, all these official repositories. And one of them is Python. So you can specify Python 3, you can specify whatever version you want. And then I have this -alpine at the end. That's just specifying this special version of Linux, a special flavor of Linux that's really light. It's a really lightweight one. I could just have Python 3 here, but I think it fires up on like Ubuntu or something, and it's pretty heavy. It's a difference of like 250 megabytes when you create this image. So we don't have any special needs for Linux, so having Alpine is fine with this case. But you go as heavyweight as you want. Then we just set a working directory on the Docker container we want to work with in this Docker file, just to make these copy commands easier later. Then we are copying over this requirements.txt. So that's a Python requirements file that just specifies the dependencies we want to load. So in this case, we're loading Boto3, which is the AWS SDK for Python. Then it's running pip install on the Docker container. So it's installing those requirements. Then we're just copying over everything inside the source directory, which is right here, to the local directory on the Docker machine, which is this working directory. Then we're running Python demo.py. So we're just running our Python file. So it's very simple. It is the entire Docker file. All the magic's really happening in this base image here. Let me pull up a terminal. So we can test this out by building it. So we're in there docker build -t, and then we're just giving it a name. And, oh, I always forget this. You need to specify the source directory where the Docker file is. So we're in the current directory, so I'm just doing dot. So that just ran through our Docker file and created a Docker image. So we can just run that Docker image by specifying the tag that we just tagged it with here, the Fat Lambda demo. Now let's instantiate our Docker container and then printed out the output from that. So it took the standard out from that Docker container and just put it here. And all that we did, we just ran this logging.info. So we see here, that's my nice line number that I like in the output, log output. So step 2 is to set up ECR and push Docker. So we need to set up the Elastic Container Repository on AWS and follow commands on how to push. And I have this logging command down here, which you'll see why we have that in a second. So I logged into AWS console, and we're going to go to the Elastic Container Service. Now here I have a couple clusters here from testing this earlier. You can ignore those. Another thing to note is I would switch to another region, but Fargate's only available in US East 1 right now, so I got to use this region again. So I'm going to create a repository. Unfortunately, I meant to delete that first one. It's going to be Fat Lambda Demo 3. And here it gives you some commands on how to build and push your image up to the repository to make it pretty simple. Now the first command is telling you to run this, but if you're on Windows, you can run this command here. So what this command up here does, I can show you. I'll just show you. How about that? What this command up here does is it uses your AWS CLI, it accesses ECR to get a login command that does not include email for this US East 1 region. So Docker has its own build and push system, so you need to log in via Docker to push to a repository. So this will actually give you a login command. Okay, so I didn't copy my default correctly. So if you have it in a different profile, you can just specify the profile. Docker will give you, or this command will give you this docker login-u AWS, and it'll give you a ridiculous password, and then give the repository URL.
Do we have to memorize that?
No.
Yes, and you have to type it manually.
Well, I can download the video and gives password.
Yeah, oh yeah, you could, yeah. So that's a temporary password, so it's just a token that lasts for an hour. So it'll, yeah. So you gotta get home now and do it.
I gotta go.
Take a screenshot. So if you're on Windows PowerShell, it gives you this command to actually run that Docker login command right when you get it, so you don't have to copy and paste it and run it again. I was like, why didn't they say anything about Linux or Mac? So here I'm saying something about it. You can actually run this command here to evaluate that command that's passed back and just run it immediately. So this is script friendly, which we definitely employ in our solutions. So I guess I just type it out manually. That always works great. So I'm going to do eval, and I'm going to paste the command and add my profile to it, and then close it off. So now I'll run that Docker login for me and say login succeeded. So next step, we have to do docker build -t, and we'll tag it Fat Lambda Demo 3. So we just copy and paste that command that it gave us. Then we need to tag this image that we built with an image tag that exists in the repository. So it doesn't work quite like GitHub where you can just push it up and then tag it there. You have to associate them before you upload it. That's all that does. And then we're going to go ahead and push that image straight up to that repository. And this is why I'm hardwired in, just so you guys don't steal my bandwidth. And this is the big layer. So each of these is a layer an image layer in Docker. So each of these for Fargate needs to be under 4 gigabytes, which is very easy to do. You saw the biggest one we had in this image was 78 megabytes. So if you're doing something with 4 gigabytes, it's probably on Windows. So we finish all these commands, you press done, and we see our image right here. All right, so that step's done. So step 3, create a Fargate cluster. So in order to run these Docker containers, we have to have these clusters. Now you can create these clusters with EC2 or Fargate or a combination of the two, but it's very simple to start it up in Fargate. So we hit create cluster. If you missed it, I hit clusters up here in ECS and create cluster. And then we have a choice between networking only, which is the powered by AWS Fargate, or EC2 Linux or EC2 Windows. EC2 Windows is it's only a couple months old. It's a relatively new addition. So with Fargate, all we have to do is specify a cluster name. And then we can choose to create a VPC or use the VPC we already created. So I'll just do create a VPC to make it exciting. I'm going to do 10.8 for each of these. And by default, it'll create 2 subnets for you, but you could create more than that if you wanted to. So now it's going to use CloudFormation behind the scenes to start up our VPC cluster and register Fargate for us. So Fargate is a managed maximum number of VPCs. Great. Fargate's a managed, just not create one. A managed serverless EC2 cluster for ECS. But in order to operate inside of our private subnets, it creates these network interfaces that Fargate can communicate through. So that's a common way that AWS will give you these network interfaces into your subnet when the services are not actually inside your subnet. Just like a virtual network interface. So we're going to view this cluster, and you see it has nothing in it right now. So it has 0 tasks in it. So while it's not being used, we're not paying for it. It's just, it's serverless. We're not using it. We don't pay for it. So we created our Fargate cluster. That's step 3. Step 4 and 5 get a little bit more complicated. So step 4, we're going to create the task definition, which will use that container that we created in step 1 and step 2. So here we're going to go task definitions, and these set up the the size of the container we want to create, and as well as the images that we're going to use. So we can specify a Fargate launch compatibility or EC2, and we're going to do a Fargate one. So we're just going to create a task here. So we can give it a task role if we wanted to access other services. But for this case, we're just accessing CloudWatch, so we get that for free. So we're not going to specify a role. And then we also have this task execution role down here. Now you could say create new role, but that actually takes a really long time to fire up for some reason when we were testing it earlier. What is better is if you create your own ECS task role, and I'll show you what that one looks like so you can create it. So if you go to IAM, you just open up another window. You just create a role, and you would want a ECS task role. So we go to Elastic Container Service. And it's Elastic Container Service task. And then we just choose the what we have here, the Amazon ECS task execution role policy. I'm just going to do task. Always pops it up. And then we're going to create that role. So we can use that role inside of our task definition. And by default, that role with this manage policy just allows you to pull images from ECR. That's very important. The Docker image needs to be able to access the container repository to pull down that image and create itself. And then it has the permissions to write to CloudWatch, so we can access log files later. So we're going to go ahead and use this ECS task execution role, which is the exact same as the one I just showed you. Now we have to specify task size, and like I said, you can go from 0.5 GB up to 30 GB. But when you choose different amounts of memory, you have different CPU options available to you. So the lowest tier of memory is matched to the lowest tier of CPU. So the valid CPU for 0.5 GB of memory is 0.25 vCPU. If we wanted more memory, then we'd have to be within the range of what's valid. So there's 50 different combinations of these memories to vCPU, but we're just going to stick with the lowest one. So this task definition, we're just specifying the size, how big it is, what role it gets. Now we need to specify the Docker container that we're going to use. So we're going to add a container to it. So we're going to add one or more containers to our task definition. But for Fat Lambda, we're just going to add one container. So we'll call this one the Fat Lambda. Now here we have to give it a URL for the image. It's not actually a URL, it's more like a Docker URL. So we can specify a public Docker container here, which I've done before, or we can specify the ECR Docker container that we already loaded up. So let's get back to Elastic Container Service in this other tab, and we're going to go to repositories, and we're going to access Fat Lambda Demo 3 that I just populated. Just access the repository URI right here, and that's the one you want. So you go ahead and paste this in here, and that's the image that we want. And then we can specify the limit of memory that this task will have access to. And since this is the only task inside of our container, or the only container inside of our task, we might as well give it all the memory, so 512 megabytes. If we had any port mappings or anything like that, we could specify them here, but it's just a task. It's not going to have a long-running port open. We could also specify all this stuff, but it's not necessary. It's all optional. So now we see we used up all the memory with that one container. We're not going to add any volumes. We're just going to go ahead and create. So now our task definition is done. So let's test it out. To test out your task definition, you hit Run Task. Now we're going to specify the launch type, what platform of Fargate we want to use. So if they come out with a version 1.1 and you don't want to migrate to it yet, you can just specify 1.0 directly, or you just use whatever the latest is. Then we choose a cluster. That is the one I just created earlier. You can fire up multiple tasks at once, or just one. And then we can create, or we can use the VPC and subnets that we want for Fargate. So we're going to use this 10.9 that I set up earlier and use both subnets. Now it's going to create a default security group for you. You can edit it to use an existing one, but we're going to go ahead and use this one that I created. Now we don't really need a public IP, but I'm just going to leave it there for now. So now you see this task is trying to run down here. We're inside of our cluster view now. See up here? And we're inside the Fat Lambda demo cluster. So we see the task, its desired status is running, but its current status or last status is provisioning. And now it's pending. So this is the point where it needs to create the network interface inside those subnets and create that container and then associate it with that network interface and actually run the task. And this could take a couple minutes really with Fargate. If you have an AC2 cluster, it actually runs faster because all that infrastructure is already set up. So I'm going to let that run for a second. And then we'll view the output in CloudWatch. So the output is going to look like this. go over to CloudWatch. I'm control clicking to open another tab. Then we're going to have created a log stream. It doesn't have any logs in it yet because the task hasn't run. If you look at this old log stream, it has a message in there that has the time, the line number, the log level, and that the Fat Lambda was started. See it back there. So it's the same log message we saw in our console when we ran the Docker container. Let's see if it ran. Yep, it ran, so it's gone. So we can go check CloudWatch. This was the Fat Lambda demo task, and we see the log stream here. So every time you run the task, it'll give you a different log stream. And we see the Fat Lambda started here. All right, step 5, set up Lambda and test it. So far, we created the ECS task, but the only way we can fire it is either manually or if we set up a CloudWatch event to fire it on a cron schedule. So if we wanted to hook it up to other events, like an S3 put or something like that, then we would need a Lambda to act as an intermediary. The Lambda can fire based on a bunch of events, and then it can fire the ECS task. And Lambdas are basically free, so why not? So we're going to create a new blank Lambda and then copy the code we have in our repository. So we're going to hit create function. It'll probably pop up another screen if you don't have any Lambdas, but you'll still hit the same thing, create Lambda. You're going to author from scratch. So let's call it Fat Lambda kickoff. I think I might already have one that's called kickoff, so I'm just call it starter. Now here in Lambda, we can specify any of these languages we want. We're going to stick with Python 3.6. We got to choose a role. It is actually important here. So they have all these roles from templates that you can choose from. But again, none of them have a template for ECS task launches yet. I'm sure they'll add it sometime soon, especially after they all watch my video, right? So we have to create our own role. We can just do that here, and then we can modify it later. So we're going to create a custom role, and we'll call this, Fat Lambda execution. Now the default policy document is to just be able to write to CloudWatch. And we could edit this if we wanted to, go freehand JSON, but we don't need to, so let's not do that. We'll just come back to this later to edit it. So we created this role down here, and then we're going to go ahead and create the function. Now the Lambda interface has changed a lot since my last video, like 18 months ago. And down here we have this Cloud9 embedded IDE. And Cloud9 is like Amazon's cloud IDE, so you can do all this serverless debugging. So we're going to use it. We're going to copy and paste. So here's the Lambda inside the inside that repository. I'm going to paste it over to the other screen. Or I can talk about it here since it's bigger. So all this does is import Boto 3, which is included by default on the Lambdas. It has a Lambda handler. And then it just has some hard-coded values in here in order to launch the task. So we're going to put in a cluster name, the task definition name, and then the subnets that we specified when we did that task run, and a security group, same thing. So with a Fargate launch, we have to specify this stuff. If we were doing an EC2 launch, we wouldn't need to specify this because the EC2 instance would already exist and it would already have all these subnets set up and everything. So for Fargate, it sets it up dynamically. So it just does that, and then it returns the response. So now we need to enter our cluster name, our task definition name, subnet, and security group. So the easiest way to do all this information, instead of going to like the EC2 VPCs and like scouring for the subnets there and all that, is just to try to run your task again. So here's the name. We're going to do action, run task, and we're going to Fargate. We're going to copy this task definition name. That's one piece of information we need. Right here. We need the cluster name that we want to fire it into. So we have the Fat Lambda demo cluster here. So we're going to use that. Then we need the subnet 1, subnet 2. So let's go get those. So we want it to be in 10.9. I'll grab subnet 1, subnet 2, and then here we can copy and paste these subnet IDs. And then we need a security group that the ECS task will run in. We can choose, let's choose a different one. So we're going to select the existing one, so we're not creating one, and we're going to use a security group ID. And they're just going to say assign public IP disabled because we don't need the public IP. All right, so Lambda function, Lambda handler. We're inside Lambda function.py, and the Lambda handler is the name of our method, so that's all perfect. So you see up here it shows the resources the function's role has access to. We don't have access to ECS yet, so when we try to run this, we could test this. We can use hello world, that's fine. We try to test this, we're going to get an error that we don't have permission to ECS. So access denied when calling run task operation. So we have to go and we have to modify this, the role we created. So I'm going to show you how to do that. So we need 2 extra permissions. And I created, this one is using Fat Lambda execution. So we'll go into the Fat Lambda execution under IAM roles, and then we're going to add an inline policy. Now here we can do a visual editing instead of using JSON. That's why we waited until here. So we're going to do the EC2 container service, which I guess is the old name for Elastic Container Service. And we're going to select the run task operation here. Now here we could specify the exact task and limit it to that task. Or we can just say all. Why not? Why not all? So this will be our generic runner. And not only that, but we need one other permission. So when we're doing this run task, we have to specify a role or a default role. We have to specify a role or also use a default role for the ECS task. Either way, we're passing a role on to this other service. So we have to have that pass role ability. So that's part of IAM. So we're going to be able to pass roles. And then we could lock this down. It's probably smart to lock this down. So I'll show you how to lock this one down. So it can't just pass any role over to the ECS task, only the default role. So if we open up IAM again, over here, we can go and get the ARN for that role. So the role we wanted was this ECS task execution role, this first one. And we can just copy this ARN at the top. So I just hit this copy button here. And then we can paste it right here. So we add ARN and put in the role. So you can call this ECS task Fat Lambda exec. And we can reuse this policy later if we wanted to. So now our policy is set up. If we go back to Lambda and we refresh it, then we can see now it has access to EC2 container service and this identity access management. And then we can go ahead and test it, and we'll get a successful response. We go over to ECS, we see our inside of our cluster, we can refresh it, and we see the task is pending, and it'll run, it'll fire, and it'll shut itself down. That's it. That's the Fat Lambda strategy. So the Lambda passed off the execution to this ECS task. You could pass more information to it, especially through environment variables. What we do is we pass over some of the SQS queues for it to check. So then the ECS task will check all those SQS queues to load up the batches. So we saved and tested. And then we can go farther. We can hook up the Lambda to actual events. We could hand it to S3 when an object is created, or we could hook up to the API gateway when a request comes in. However you want to hook it up, you have all the power of Lambda at that point for hookups. So Fargate actually costs about double the price of similar EC2 on-demand instances. What you're paying for with Fargate is the simplicity, where you don't need to manage that auto-scaling for ECS. So in conclusion, ECS and Fargate do not directly replace Lambda, but Lambda is enhanced by these tasks, these ECS tasks and services. So ECS provides more power and customizability than Lambda, but there are several costs. Like there's the cost of the actual literal cost of it, and then there's the cost of you have to learn Docker, and the cost of it takes longer to spin up these Docker containers than a Lambda. But if you need it, it's definitely a great tool to have in your AWS toolkit. Thanks for watching. If you have any questions, please feel free to email me at danrusk@thorntech.com.